Howdy, y'all. We are talking about concentration today, so let's get to it of our solution chemistry. So, there are three types of solutions when we're talking about concentration. Now, there were three types of solutions when we were just talking about types of solutions, when we talked about solutions and colloids and suspensions. But when we're talking about concentration of solutions, there are also three categories. Those three categories or types would be one, saturated solutions. These contain the maximum amount of solute that will dissolve in a given amount of solvent at a given temperature. So, maximum keywords here are maximum amount, but this is stuff to go into your notes. Maximum amount of solute, and that will dissolve in given amount of solvent at a given temperature. Okay, so keywords are maximum. For some reason it doesn't let me do it with the little boxes. Don't know why. All right, let me, okay, there we go. All right. So maximum amount of solute that will dissolve in a given amount of solvent. And again, this is at a given temperature. Now the next one is unsaturated solutions. Now unsaturated solutions are more solute can dissolve. This is indicated by no solid being present. Okay, so unsaturated solutions are those like when you add tea and when you add sugar to your tea and you can still add more sugar and it'll dissolve and no solid will be at the bottom. Now when you have a saturated solution, this will be like the tea that has so much sugar in it, there's some always sitting at the bottom. Doesn't matter how much you stir it, it just always has some at the bottom. And that would be a saturated solution. So saturated, maximum amount, unsaturated, more could dissolve. Now, supersaturated solutions are more solute is dissolved than is theoretically possible at that given temperature. So we have certain solubilities at certain temperatures, but this is saying we can have more than that. So that is kind of, it's over the amount of than it's supposed to have. Now you can actually, so if you look at these, the bottom one, I have a saturated solution. There's no solid at the bottom, but it's holding as much as it can hold. I actually heated it up and got it to dissolve a whole lot, and then I cooled it down so it's holding more than it should hold. So it becomes a super saturated solution. Then when I add a crystal to it, it actually comes out of solution. So that's kind of one of those things that when I push it over the edge, it'll pull the rest of the crystal, it'll crystallize. That's how I know that this first one was a super saturated solution. All right, so answering that next part of your notes, how could you determine if a solution is saturated, unsaturated, or supersaturated? If solid is present at the bottom, then it is saturated. If no solid is present, it is either unsaturated or supersaturated. To determine which of these it is, you're going to add a crystal. If you add a crystal, the unsaturated will dissolve that crystal. But if you add a crystal, and the supersaturated solution will crystallize and the entire solution will become a crystal instead. It'll become solid. Okay. And I don't know if this will let me play this while I'm recording. I don't think it will. Maybe it will. Yeah. So you were hopefully able to see that video about a supersaturated solution. So again, if you add a crystal and it all crystallizes, then it's supersaturated. If you added that crystal and it would just dissolve, then that would have been an unsaturated solution. Now, there's another way to go ahead and see if something is saturated, unsaturated, or supersaturated. When you're using your solubility charts, if, for example, I say I've got 40, um, let's say I've got a temperature of 40, and I want to talk about KCl, all right? And so I go up and I say that I've got actually 30 grams in it, okay? Well, if I've got 30 grams is over here, then that's going to be right here. Well, the line for solubility is right above that, okay, in that darker blue. So if that's the case, this would be considered unsaturated because it's below the line. So if it's below the line, and you might want to write that in your notes, if it's below the saturation line on a solubility graph, then it's unsaturated. Now, instead, if I had said that there was right at, let's say, 38 or so, so if I was like right here below the line, below 40, then that would put me right on the line. Now, that would be saturated. So that would be how we determined whether it was a saturated or unsaturated solution. Now, I could also continue on and say, okay, actually, it's holding 50. Okay, so it's way up here. And so if that's the case at 40 degrees, if it's holding 50 grams of KCl, then that's more than it's supposed to hold at that temperature. Okay, so that's what we would also call supersaturated. All right, so the other way to say that is also if I said that I heated it up and I got 50 to dissolve in it, and so that's, or I got 50, so I heated it up to a higher temperature, maybe like to 75 over here. And I got 50. And I got 50 to, let me see if I can get my screen back. Okay, so I got 50 to dissolve in it, which would be at 75 over here. And then I cooled it down to 40 and it was still holding that 50, then that is why it's supersaturated. Okay? All right. So that should help you also answer several of your questions in your classwork. Now we can also talk about our concentrations as concentrated or dilute solutions. When we talk about concentration, we're really talking about the amount of solute per given amount of solvent. Okay, so concentration you guys are very aware of when you think about how you like your Kool-Aid or your tea or those kind of things. Now, dilute solutions have a small amount of solute in them, where concentrated solutions have a large amount of solute dissolved into the solvent. So when you think about it in those ratios, dilute would be like if I put a spoonful of my Kool-Aid mix into water, where concentrated might be if I put like a cup in my glass of water. So this is actually showing you um, cranberry juice, and cranberry juice comes from concentrate, and then that you can dilute it and it can have different concentration values. So you can make it have less of the cranberry juice each time. Okay. Now, when we were talking about molarity, some of the solutions that we dealt with in our previous demos, we were talking about molarity. And if it said that there was like it was a 1 molar solution, then what that was saying is it contained 1 mole of the solute for every liter of the solution that we made. Okay. If it was a 0.5 molar solution, then it was like of sodium chloride, then it had 0.5 moles of NaCl for every 1 mole or 1 liter of total solution. Your formula for molarity, which happens to be on your formula chart, is moles of solute over liters of solution. So this is something that we'll use in our calculations. So hopefully you do have your calculator. If you're going to make a solution of a known molarity, this is logistically what we do in the lab when we prep for labs for you guys. So we measure out a specific amount of the dry solute, okay, whether that's salt or sucrose or any type of those types of solutions. Then we're going to add just enough solvent, so we'd add enough water to dissolve the solute. And then we'd add a little bit more if it didn't dissolve all the way. And then what we would do is we would add enough water to fill it to the 1 liter line. This is a volumetric flask. And so when we use these volumetric flasks, we actually have a marker on them for 1 liter or 2 liters and things like that. So we can actually fill them exactly to the amount of the solution that it's supposed to be. So by measuring out the dry mass, we're measuring the mole amount that we need to make the molarity. So if we were just making a 1 molar solution, we'd measure out 1 mole of this dry substance, which then we'd actually measure it in grams. And then we would add enough water to dissolve it, and then we'd fill it up to the 1 liter line. And that would make a 1 molar solution. So what is molarity of a solution made with 1.25 moles of NaOH in a 4 liter of solution? So molarity's formula is moles divided by liters. We're given our 1.25 moles, and we're given our 4 liters. So logistically, all we have to do on this problem is plug them in. Hopefully, like I said, you do have your calculators, and you have typed in 1.25 divided by 4. So our molarity should be 0.3125, but since we can only have 2 significant digits, that will become 0.31 moles. Or molarity, not just moles. So that's our concentration of that solution. The next example, a student measures 125.5 grams of NaCl and dissolves it into a 1 liter of water. What is the molarity? Well, our molarity formula is number of moles divided by number of liters. So the first thing we have to do is convert from grams to moles. So when we're doing that, we look up the mass of chlorine, which is 22.99, and we look up the mass of chlorine, which is 35.45, I believe, and we add them together. Okay, that gives us the 58.44 grams. We then take our 125.5 grams, divide it by 58.844 grams, and multiply it by 1. That cancels out the grams, which then gives us the number of moles that we would need to measure actually on the balance, or the number of moles that we're going to end up with. So we're going to measure out the 125.5 grams on the balance, but that's representative of 2.15 moles. So to find the molarity, we take that number of moles, the 2.15, and we then divide it by our number of liters. Since our liters in this problem is just 1, then our molarity would end up being just 2.15. Now, because originally I only have 1.0, my significant digits have to be rounded to 2, so that molarity would be 2.2 moles. All right. Now we can also do dilutions. Now diluting a solution won't change the number of moles of solutes, it only changes the concentration. Now this formula works only for dilutions of a solution. Don't use it in reactions. If we're doing a reaction, that's a stoichiometry calculation. But if we've got the molarity of a solution and we've got its original volume and we need a certain molarity and we know how much volume we want to use to get to that, then we can find, if we have 3 of these variables, we can find the 4th. So for a lab, we need 500 milliliters of 4.25 molar hydrochloric acid. Our concentrated hydrochloric acid is 12 molar. So how do we make up this solution? Okay, so we know that the original molarity that we have is 4.25 and that we want 500 milliliters of it. Now we're using 12 molar hydrochloric acid, which is exactly what we do in lab when we need smaller amounts of different concentrations. So what volume will we end up needing to use of this higher concentration to make this lower concentration? So we can plug it into the equation. 4.25 multiplied by 500, then you would divide by 12 because the opposite of multiplication is division to get our V2 by itself. So you'd end up with 177 milliliters of it. So I'd measure out 177 milliliters of the 12 molar acid. I would put, I would add that then to enough water to make a 500 milliliter solution, and I would stir it because it'll actually make some heat. So that would be how I would make it. Now we also can talk about percent solutions. And this would be, we can talk about percent of volume per volume or percent mass by volume. Really all it is it's taking the volume of the solute over the volume of the solution, or it's taking the mass of the solute over the volume of the solution. And then we're multiplying each of them by 100. It's very much like how we do our hydrates when we take the mass of the water over the mass of the total crystal. This is the same thing. We're just taking it of the solution, the volume of the total volume of the solution, or the of each of these. So rubbing alcohol is 70% isopropyl alcohol by volume, which means when you buy it at the grocery store, it comes in different percentages. So how many milliliters of isopropyl alcohol are actually in a 250 milliliter bottle? So what we can do is this would be a volume by volume percentage. Since we know the percentage is 70% and we know the volume of the solution is 250, we can figure out how much of the isopropyl alcohol is actually dissolved into that water. So it would look like this when we set it up. 70% would then get divided by 100, which becomes 0.7. Okay, and then we would need to cross multiply by the 250 to find the x. That would end up giving us 175 milliliters of isopropyl alcohol. So the first thing I did math-wise was divide by 100. So that gave me 0.7. And then I cross multiplied the 250 to solve for x. Now, if the percent mass by volume for a solute is 6.8%, then the volume of the solution is 42.6 milliliters. What mass of salt is present in this solution? So this again, we know the percentage of mass per volume. We know the solution volume, and so we could find the grams of solute. So mass divided by volume times 100 gives us our percentage. So the first thing we'd want to do is divide by 100 of the 6.8%, and then we would multiply by 42.6 milliliters. That would give us this very large number of 2.8968, which we would then have to round to 3 significant digits. So that would be 2.90 grams. All right, that should wrap it up for us. Have a good one.